Good evening, kids. I am your Sridhar sir, physics teacher. Today we are going to discuss the 3rd April shift 1, the morning shift, JEE Main 2025, the physics paper with the solutions. So the paper is moderate. I think there's a third paper what we have come across and it's a moderate paper. Number of easy questions are 10, the tough questions 4 compared to the other two shifts. There's a third one. Little bit some tricky are there, around 4 are there. Moderate questions will be 11. Hmm? And overall the paper is moderate and easily all just revise the concepts, formulas. They were able to manage 20 to 21 questions very comfortably. So the coming shift also all preparing the afternoon shift. Then next again on the 4th, 7th, 8th. The methodology is same. Read all the theory. What is our targeted? How much of syllabus you have put target? 50%, 60%, 70%, 80%. Those who are targeted 90%. You read all. Then afterwards, revise all the formulas. Recollect. Ask yourself, do you know this formula? Do you know this formula? Do you know, can you remember this formula? I think focus more on that one. So like that you keep on read things and check yourself, are you comfortable with this content, this content? Hmm? So set right everything, get ready for exam. Really, the papers, the way the physics being asked, manageable. Till now, it's manageable. Maybe if at all tough comes, maybe 2, 3, 4, 5 questions will be tough. But still, I think the 20 questions will be there in your hand. And check all the topics like the missing topics is what definitely you have to give priority. What all topics till now? I think by this time evening, 4 shifts, 4 papers came. Those who are writing on the April 4, definitely whatever you check the concepts which till now didn't ask, they'll become important. Those are writing on 7th, 8th. All the topics which are asked, still what is left over, I think they are the probability. Like that, you can make a guess. So, suppose you made a guess of around some 50 subtopics, in that maybe 10 or 8 will help you. So many strategies are there. It all depends on your patience. The paper is moderate, not an easy, it's a moderate paper. Okay, we'll start with the paper discussion. Okay, there's a question now. The first question, it belongs to the chapter oscillations or SHM. The subtopic name is SHM of spring block up in a block system with friction. There are 2 blocks are there. You can see here. There is a 1 block. Next we have the other one is another block. There are 2 blocks are there, and this is spring connected, and the surface between the blocks is rough. Let me read the question. The figure below shows an oscillating system of 2 blocks and spring. The horizontal surface is smooth. This is smooth. This surface is smooth. And the contact between the blocks is rough. This is rough with quotient of static friction mu. Consider the blocks of mass m is always stationary relative to m, means no slipping. Always stationary means no slipping. Choose the correct option regarding the statement below. Maximum frictional force between the blocks is mu mg. What is the maximum frictional force? Maximum frictional force between the blocks is mu mg is telling. Then the time period of oscillation, definitely the time period of, this is a correct statement, because what is the total mass of oscillation? Small m plus capital M. Friction between the blocks at any instant of time. Friction between the blocks. So we'll do one thing. When these are oscillating, here spring force will act. And with this. So the friction force here it will be like this. Then what is x? X equal to a cos omega t. And the friction force and the acceleration of this will calculate a equal to minus omega square x. Then this will become minus omega square a cos omega t. The maximum possible acceleration is omega. What is omega? Omega we know time period. From here we'll get the omega. Omega will be k by capital M plus small m into a. There's a maximum acceleration. Okay, fine. So there's a maximum acceleration. Then who will accelerate this upper block, the friction? M into A max. This will be the maximum friction force. M into K M plus small m into A is the amplitude. We are going to determine the amplitude. So tell me, like, what is the maximum frictional force between the blocks? Depends on this quantity here. It all depends on this one. So this will be ruled out. Frictional force between the blocks at any instant of time. The frictional force, in fact, will vary here because the acceleration is a function of x. Frictional force is a function of x. The frictional force itself will vary. And it will be varying like this, the graph. Very good concept, it is. Okay, the graph like this. Okay, now it varies at any instant is, no, this is not like, it will vary like at any instant of time, this equation. So this is also ruled out. So only A is correct. A, B, C, all three are correct. B and C are correct. No, only B is correct. Very little bit tough question. You could, you should avoid. If you have a time, okay, you have to work out. You should think all these ideas. Then you can pick up the suitable option. We'll take the next question. There's a question belongs to the chapter capacitors. The idea in what is capacitor partially filled with the dielectric slabs. Is a composite dielectric slab is filled up. So here they are in series. The effective capacitance 1 by C1 equal to epsilon naught E1 A by D by 2. Epsilon naught E2, the dielectric constant, this is the dielectric constant, A by D by 2, or this will become 1 by C1 D by 2 epsilon naught A D by 2 epsilon naught then these two are in parallel. Effective capacitance will be epsilon naught E1 A by 2 D There's a capacitance. This will be D by epsilon naught C1 by C2 is asking the ratio of C1 by C2. We'll take like this, C2 by C1. Later on we'll take the reciprocal, no problem. Or C1 will be, solving here I'll solve it. C1 will be 2 epsilon naught A D then we'll C1 by C2. This one only. Next denominator epsilon naught A2D D will cancel off, so 4 whole square. This in detail will be given. So these are the this will be ratio of C1 by C2. This will be your option. So I think you should remember this formula. It's a partial filter. They are here in series. These two capacitors. This will become one capacitor. This one capacitor series. We use this formula. They are in parallel here. Okay. Huh? We'll take the next question. This question belongs to the chapter kinematics. The idea involved is projectile motion with the graphical analysis. Let me read the question. From a horizontal surface, a particle is projected with a speed u. Which of the following correctly represent the variation of maximum height above the surface attained by particle as the angle of projection is varied? Here what we have the situation like this. There is a this is a surface. Here I am going to project with a speed u at an angle theta. Then is going to describe the projectile motion. This is a maximum height. So this maximum height ascended depends upon u square sine square theta by 2g. Put theta 90. When theta is 90 degree, it is the maximum height ascended. Just its height. Maximum height is u square by 2g for theta equal to 90 degree. As you keep on increase theta, h will increase. Okay, this is ruled out. At theta equal to 90 degree, it will be maximum. So this is something like a maximum. Okay, this is a rule out. Okay, fine. Here we have the condition. Now, according to these two graphs, so what it's telling is like somewhere at one particular angle, the maximum height will be 0. This is not possible, no? The maximum height should keep on increasing here. So only this is the better option. You need not to do one thing. First odd one out, then something here at a specific angle it will become 0. The height ascended. The height ascended can never be 0. Only when theta 0, h will be 0. H will be 0 only for theta 0. Theta 0 only, it should be like a maximum height ascended should be 0. So this becoming 0 at certain non-zero value of theta not possible. So therefore I am not picking up this graph. You need not to bother about this shape of the graph. Roughly you have to estimate. We'll take the next question. And this question belongs to the chapter work energy power. And the idea involved is conservation of mechanical energy. The question is, an object is dropped from a height s. At a point, its kinetic energy is 3 times its potential energy. Find its height from the ground and speed at that point. So here basically we are going to drop a particle where the particle is dropped from here. Drop it from rest. What is the height? Height will be s. Then when its kinetic energy is 3 times its potential energy, somewhere here it will happen. What is the kinetic energy at this point? The kinetic energy at this point, it will have the kinetic energy, it will have speed, and it will be at height h. Find the height from the ground and speed at that point. What is the kinetic energy here? Will be 3 times that of potential energy. What was the initial potential energy? mgs. The total energy should be conserved, no? Yes. U naught, it is released from rest, plus K naught. I'll solve it here. Should be equal to K plus U, kinetic energy plus potential energy. U naught will be mgs, kinetic energy is 0. There's a kinetic energy. Find its height find the h and speed we have to calculate. So what is the potential change? Potential change will be k by 3. So this will become mgs equal to 4k by 3. mgs equal to 4 by 3. What is the kinetic energy? mv square by 2. So this will become v is equal to 3gs by 2. That's the speed. After this we have to calculate the h, and we know what is the potential energy. Potential energy will be k by 3, and potential energy is what? mgh. This is h equal to 0. Kinetic energy, already we know kinetic energy. Kinetic energy will be 3 mg. K by 3 will be mgs by 4. Take help of this one, this equation. So why u equal to k by 3? Because it is given condition, no? There is a given. So therefore k by 3 will be mgs by 4. So what is h is equal to now? H equal to s by 4. Good question. You should really analyze. This is the conservation of mechanical energy concept. Oh, yeah. Let me go for next question. Okay, kids, we have the question. This question belongs to the chapter electrostatics. The idea involved is potential of a conducting shell. Inside, on the surface, outside. The basic formulas, if you know, you can manage this question very easily. Let me read the question. The electric potential at the surface of shell of radius 10 centimeter is 120 volt. So what is the potential on the surface? Here 0.3. This should be equal to kq by r, kq. There's a value of kp, and how much this is equal to 120 volt. This is given for us. Then potential inside everywhere will be same as that on the surface. We know V1 equal to V3. Potential at a distance R equal to 15 centimeter. Then potential outside will be KQ by R. KQ by R. So let this R, here capital R, here capital R will multiply. KQ by capital R, R by small r. KQ by capital R, 120. Capital R is how much? Radius. Radius is how much? 10. This is 15. So that we can calculate the potential outside will be 120 into 2 by 3. 80 volt. So potential here 80 volt on the surface, 120 volt, everywhere inside 120 volt. This will be your option. A simple idea: potential on the surface, potential on the surface, potential inside will be that on the surface. Potential outside depends on the radial distance. I think the basic definitions of potential of conducting shell, if you know it, you can manage this question. Okay, fine. Okay, this question belongs to the chapter fluid dynamics, and the idea involved is Bernoulli's theorem and velocity of reflex. These are the basic concepts. Okay, container of height 1.6 meters. What is the height of this? 1.6 meter. Is having a small hole at height of 0.9 meter. The small hole from the ground. Find the speed of Flex from the hole. Is asking to get this velocity. The velocity of Flex out of 1.6 meter, how much will be left over? H will be 0.7 meter. Then what is the velocity of Flex? Velocity of Flex formula will be root of 2gh. What is the depth of the hole? 2 into 10 into depth of the hole will be 0.7. This will be root 14 meter per second. So approximately nearest value will be 3. G 9.8 is telling. 9.8. Okay, let me multiply. Okay, we'll take the value of G. It is given 9.8. 13.7 will come. Under root of this will be 3.7 meter per second. Okay, these are the options available. Just now I checked it. So we can pick up this as option D. This is the velocity of Flex. It just depends on the depth, this particular depth of this hole. This is a small hole. At what depth it is from the free surface. Okay, fine. Huh? So on what basis I'm writing this equation? Because the hole is here. The velocity of Flex depends upon the depth of hole from the free surface. This is the free surface. So 1.6, 0.9 will be 0.7 meter. That we have substituted. Okay, then. And the chapter is moving charges and magnetism, and the idea involved is F equal to BIL. A current carrying wire kept in a magnet field, then how much of force acting on it. This is a current carrying wire, the length of this is L, current carrying I. We have to calculate the force. The force, resultant force will be acting on in this direction, which is equal to BIL. Magnetic field 0.15, current flowing is 8, length is 4 meter. Force in millinewton is asking. 8 4 are 32. So this will be 0.15 into 32. 4.8 it will come. Convert that into millinewton, we'll get this answer. A simple idea based. Huh? Just if you know F equal to BIL, that is enough. No, he didn't give any diagram, just only that is telling the magnet field is perpendicular to the current carrying wire is placed perpendicular to magnet field. So this basic diagram, you should have the imagination. And this is a wire itself. Okay, kids, done? We'll move now. We'll move to the next question. Okay, this question belongs to the chapter radiation. And the idea involved is radiation pressure. A point source of power 450 watt is emitting light in all directions. So I have this is which will emit light in all directions. It will emit in all directions, not only this. At a distance of 2 meter is asking what is the radiation pressure. 2 meter, okay, we'll choose somewhere here. This is 2 meter. At this particular point, there is a power of source. We have to calculate the radiation pressure. So first we'll calculate the intensity. How you calculate intensity? Power by x square. What is x? X is a distance. Power will be 450, 4 pi x square, 2 square. 450 by 16 pi. This is the intensity of light at this particular point. What are these lines? Light propagating. Then what is the radiation pressure? Given by I by C. 1 by 3 into 10 to the power of 8, 450, 16 pi. This will be approximately 2. So 450 by 16 pi. 16 pi is what? Pi will be 3, will be around 48. Here we'll get the 10. This will be 0.33. 10 to the power of 8. This is approximately 10. So the final calculations will be 3.33 into 10 to the power of 8. Approximate 3 into 10 to the power of 8 Pascal. It's all about calculations. Here is what the tricky calculations are there. Hmm? Okay, fine. We'll move to the next question. The chapter name is rotational motion and the idea involved is accelerated rolling motion. Then we have this sphere, a force 49 Newton force is acting and assuming no slipping here. So definitely the friction in what direction will act? The friction will act as a sphere. The friction will act in this direction. Center of mass will accelerate. It will set up a torque. Pure rolling is this. Now we'll write down the equation. F plus small f equal to ma. It will set up a torque about 0.2 applied force F into R, torque by friction force equal to I naught alpha. For pure rolling equal to R alpha. Further we'll solve it. F minus small f into R 2 by 5 mr square. Alpha will be A by R. F minus small f will be 2 by 5 ma. Acceleration of the sphere we have to calculate. So there's a one equation, this other equation. This will substitute here, or we'll add up these two equations. So 2f is equal to 7 ma by 5. What is acceleration equal to? 10f by 7m. F will be 49, 7 into 20. 7 by 2 meter per second square, which is nothing but 3.5. Very, very, very important decisions you have to take it here. There will be rolling friction will be acting. Sir, why you are assuming forward? Because definitely you apply the force at the threshold point. No? For solid sphere, what is the threshold point? 2r by 5. It is acting above that. So therefore the friction will act forward. No sir, I'll assume backward. As you assume, still you'll get the same answer. Whether you assume friction forward or backward, you'll get the same answer. There are only two possible directions of friction, either forward or backward. Here you can assume any direction, you'll get this answer. You assume any direction. If you solve it, if you get negative, change direction. If you get positive, what you assumed is right. We'll move to the next question. Okay, this question belongs to the chapter ray optics, and the idea involved is lens maker formula. A biconvex lens. There's a convex lens having radius of curvature. This is 10 centimeter. This is 15 centimeter. The focal length of the lens, we know how much? 12 centimeter. Is asking to calculate the mu of the material. Or the formula, lens maker formula, 1 by f equal to surrounding medium is air. If you didn't mention anything, you should consider air. Mu minus 1 by r1 minus 1 by r2. Why? Because there's a incident ray is moving towards right. R1, the radius R1, center of curvature will be here. So the R1 you will measure in the direction of incident ray, whereas the R2 will measure opposite to incident ray. So therefore this will be negative. Focal length, this is 12. Mu we don't know. R1 will be plus 10. I'll do one thing. I'll substitute now with sign. R2 will be minus 15. Solve this. We'll get mu 1.5 or 3 by 2. Directly the lens maker formula. The chapter name is moving charges and magnetism. The idea involved is Biot-Savart law. The problem is based on Biot-Savart law. A current carrying wire is bent as shown in figure. Magnetic field at center of the semicircles. Take R1 equal 4 pi, R2 equal 6 pi. We have to calculate the magnetic field. Here the current I is flowing. Then there are four segments are there: semicircle, straight segment, and semicircle. No magnetic field due to straight segment because the pointer will lie on the axis. There won't be any magnetic field due to this straight segment. What all magnetic field will be there? Only due to this semicircular one. So the net magnetic field at point O due to this wire will be into the plane. Mu naught I to R2. Angle subtended. pi, or say magnetic field due to the semicircle will be 4r2. This will be into the plane. The current will flow, will be out of the plane. Substitute all these values. R1 equal to 4 pi and R1 equal to 4 pi and R2 equal to 6 pi. Solving this, we'll get this answer, nearest value. What is the value of mu naught? Mu naught value will be 4 pi into 10 to the power of minus 7. So substituting, we'll get answer in terms of current here. The one into the plane, you take negative. The one which is out of the plane, take it positive. The problem based on the dual nature of matter and radiation, and the idea involved is the photoelectric effect. The work function of metal is 3 electron. The color of the visible light that is required to cause the emission of photoelectrons. Definitely the wavelength of the light should be equal to 3 electron volt. Then lambda should be equal to Sc by the energy. Sc will be 1240 Armstrongs. The energy will be in the electron volt, 3 electron volt. So this will become 12400 by 3. This will become 4133 Armstrongs. Then if you compare the spectrum, Vibgyor spectrum, this will be 4000 approximator, and this will be 7000. And what about the yellow will be this one, and the green will be around 5500 Angstroms. So definitely yellow is ruled out, red is ruled out, green is ruled out. So therefore it has to be the blue. I think the spectrum, you should remember the EM waves concept. Rough idea, what is the wavelength of the blue color light, indigo, blue, green. We know for red and yellow will be the average of these two. Definitely this will become green. Definitely the green should be the lower value compared to yellow. Then the blue should be lower value. So therefore it has to be beside the green, it should be blue only. Okay, this question is based on the current density, and the idea involved is the resistance of a wire. Some series parallel concept is there. Parallel, resistors in series. Sorry, resistors in parallel. So I have the there is a wire. Then here it will have the half of the resistance, R by 2, and they are parallel. So the effective resistance RAV will be R by 4. What is R? R is the total resistance. R will be rho perimeter length L area of cross section. So 1 by 4 it will be. So RAB will be. So rho will be 2 into 10 to the power of minus 6. Length is 25 meters. Area of cross section 5 millimeters square. Ten ohm. Then R by 4. 2.5 ohm. Now, somehow this diagram you should imagine resistance across the diameter. We'll move to the next question. Okay, this question belongs to the topic current density. And here the emitter concept. The idea involved is emitter. We have here the emitter circuit. It is having the resistance how much? 240 ohm. Is asking to get the reading of the current through the emitter, or reading of the emitter. Let the current flowing here be I. Here let it be capital I. Here how much it is? I minus I. Will give the polarity. These two are parallel, the drop should be equal. So based on that, 240 into I, applying the Ohm's law. The resistance of the emitter is 240, the current is I. This should be equal to 10 into I minus I. So 240, 250 I equal to 10 I. The equation will be 25 I equal to capital I. We'll write one loop equation, plus 20, here, plus 20 minus 150.4 capital I minus 240I equals 0. We have to replace capital I. $25I. So 25 into, we have to do the calculation, no? 25 into 150.4, 3760. So this will be 20, will be 4000 I, or I is equal to 1 by 200. 5 milliampere. Good calculations. Calculation better. You should be very good in calculations. You know all this KCL, KVL, parallel series. It's all about this calculation. Okay, sir. We should be perfect in calculation. Yes, definitely. We'll move to the next question. Okay, the chapter name is thermodynamics, and the subtopic is adiabatic process. A ideal gas with adiabatic exponent 1 gamma initially at 27 degrees compressed adiabatically from 80 cc to 20 C. The final temperature of the gas T1 V1 gamma minus 1, T2 V2 gamma minus 2. Initial temperature 27 degrees. 27 degrees in converting to Kelvin will be 300 Kelvin. Volume of this gas is how much? 80, 800 gamma minus 1, T2. The new volume will be 200 gamma minus 1. The units you not to bother will cancel out here. T2 is equal to 300. This will be 8 by 2, 4. Gamma value will be 1.5, 1.5 minus 1, 300, 1 by 2, 4 to the power of 1 by 2. So this will be final 300. 4 we can write 2 square, 600 Kelvin. This formula you should remember, adiabatic process. Temperature, volume, pressure, temperature. Directly remember the formulas. And the units you need to bother, because the units of this cc and here cubic centimeter will cancel out. No need to convert again to the cubic meter. Directly you can bring it in, it will get cancelled out. Okay, we'll go to the next question. Okay, the question belongs to wave optics. The idea involved is YDSC with intensity of slits different. Usually intensity of slits will be same. Here intensity of slits are different. Then the formula for the difference of maximum and minimum intensity. I max. The difference is asking delta I equal to I max minus I minimum. What is I max? Root of intensity of this will be 9I plus root 4I whole square. Root 9I minus root 4I whole square. This will be 3I plus 2I whole square. This will be 3I minus 2I whole square. 25I minus I will be 24I. This will be the difference in intensity at the maximum and minimum point. You need not to bother, sir, like a fringe width, I don't know how many fringes. Need not. Exam is all about question answer. It's all about marks, rank, not knowledge. Fine. When you are learning, okay, think, analyze. But in exam, it's all about question answer. Nothing. What is needed, only you have to think here. There's a question based on the gravitation and is asking about the units and dimensions. In gravitation, we'll come across many quantities, the dimensions. So first I'll start with the acceleration due to gravity. Acceleration due to gravity is nothing but the acceleration only. What is the dimensions for acceleration? The dimensions for acceleration will be m0 l1 t minus 2. So here for d it will be 1. Okay, d it is 1. I'll write it here. Then again, we'll take care of the gravitational potential energy, because we know energy will have same thing. So for gravitational potential energy, what will be the dimensions? m1 l square t minus 2. m1 l square t minus 2. I think gravitational potential is here. B will be 3 and D will be 1. B will be 3, D will be 1. You need not to bother about B is 3 here and D is 1. What about, sir, A and C? You need not to cross check. Directly you have to save time and you have to jump. Okay, sir, but you are not verifying. In exam, what is needed? You got the option, no? Okay, sir. Like if the correction is there, then particular add marks will be there. You need not to think on this one. That with the help of B and D, what you have to make a guess and you have to come out. Not guess, because there for B what happened, you can look at here 4, 2, not possible. D, okay, all are 1. I think the question asked so that you should not verify these two. Only take help of this and conclude. It's all about the thinking you have to do in exam, how to save time. Well, this question belongs to the kinematics, based on the kinematics graphs. Which of the following curve possibly represents one-dimensional motion of a particle? There's a position versus time graph. Now, definitely you take the slope, the direction of motion will not change. So there's a one-dimensional motion. Then there's a velocity or displacement graph. This will be like a oscillatory, similar to SHM. There's an oscillatory. There's a uniform velocity. All these are one-dimensional motion. There's also distance by time, position versus distance versus time. There's also 1D motion. VT graph, you can see the direction of velocity. With the time, the velocity vector keeps on changes. So this will not represent one-dimensional motion. So which all will represent A, B, and D. Okay, sir, why option C you are not picking up? At various instants, at t equals 0, it's having velocity. At instant of time, its speed will change, and also the direction is going to change. So therefore, this will not represent the one-dimensional motion. Okay, we have the name of chapter, waves and sound, and it's an organ pipe. The resonant tube experiment, there's a tuning fork. The tube is initially fully filled with water, I'll drain out this one. I'll decrease the level of water. So here we'll be having a tap. Using this tap, I can decrease the level of water. Then there's a air column. The first resonance will occur at length 100 centimeter. Next resonance will occur at length L2. Then first resonance will be this will be opponent, this will be antinode, this will be node. This will be again antinode, node, node, this antinode. So half loop, 1.5 loop. So what is L2? L2 will be 3 lambda by 4. L1 is lambda by 4. So L2 minus L1 equal to 3 lambda by 4 minus lambda by 4. Lambda by 2. L2 value we know 140, this 100. This will become 40 centimeter. Lambda will be V by 2F. It's asking to get the speed of sound. Frequency of the sound is how much? 400 Hz. So speed of sound will be 1632 centimeter per second, or this will become 320 meter per second. Convert 100 centimeter become meter. Your answer will be 320. Directly, if you should know this particular formula in exam. You can't draw the diagram, everything. Directly you should manage. L2 minus L1 equal to V by 2F. There's a formula. You should be ready with this formula. Consecutive successive resonances, these are. Chapter name is Semiconductor Physics. We have the logic circuit and truth table. There is a truth table when it is given like this: 0, 0. When both inputs are low, output will be low. When both inputs are high, output will be high. I think this truth table is directly related to AND gate. Where to check it? Is there any AND gate is there? Here it will be A complement, B complement. Here we have the negation. So there is the OR gate. A complement, B complement, whole complement. Then what is Y is equal to? Y is equal to A complement plus B complement, whole complement. So then this will become A complement, A double complement dot B double complement will be A dot B or just AB, which is nothing but the AND gate. I think this will satisfy. You check all the things. Here this will be A, B. Here A plus B. Here some. Here no, there's no connection. Then this will become B complement, this OR gate. So what is Y is equal to? A plus B complement. For this I am discussing A plus B complement. B0, B plus B complement will be 1. A plus 1 will be 1. I think it will not represent this one. Then what about here, sir, this design gate? A complement, B complement. Y equal to A complement dot B complement. There's a NOR gate, so will not satisfy this. Similarly here, A, okay, come for this one. A, B, design gate will be AB. This will be B complement. Then this is Y is equal to AB dot B complement. Will be 0. Only this will satisfy. Okay, now I think really some little bit you have to think of. You can't directly choose it. You have to think it. There's a using mathematical equations, logical circuits. You have to analyze here. We'll choose the next question. Okay, kids, this is the last question I'm having. Chapter name is sufficiency, and the idea involved is excess pressure in the soap bubble. Excess pressure in bubble A is of that bubble B. Find the ratio of volume of bubble A to bubble B. So we'll calculate the pressure. Outside pressure is P naught. The excess pressure is telling. So delta P A, this should be equal to 4 times of surface tension by RA. The excess pressure in bubble B will be 4 times of the surface tension by RB. Of bubble A is half of it. So what is the condition given? Delta P is half of this one. So this will become 40 by RA, 40 by 2RB. RA equal to 2RB. Find the ratio of volumes of the bubble. Volume of bubble A to volume of bubble B will be RA by RB whole cube. 4 by 3 pi R cube. RA by RB will be how much? Will be 2 cube. Will be 8. Eight is to 1. Okay, kids, we have discussed the paper, the 3rd April, the shift 1. You can see that paper little bit more calculations involved. That's all. Rest of everything okay. All formulas and calculations. Because of that, we are calling moderate. If less calculations there, it would have been easier. And what all the moderate questions? What I am putting here. These are the moderate questions. These moderate questions are because of lengthy calculation. Otherwise, the concept involved is easy. Concept involved is easy. Because of calculations, we are calling them moderate. And there are some 4 questions are there which are a little bit tough, where you should think, analyze. So altogether, okay, it's like a one who has read, remember formula, is able to do this paper very easily. Scoring even 90, 94, 96 marks, also very easy. So it all depends on the preparation. So the coming, what you have the 4th April, 7th and 8th April. That the methodology is read, remember formulas. Okay, agree this. There's the only thing which will help you in the exams. Huh? Revise or read how much all possible. Recollect, recollect. Hmm? Okay, fine. We'll end up this paper discussion. Once again, everyone, thank you very much for great support. We'll end up tomorrow. This 3rd April, the second shift is there. Shortly, I'll upload it. Thank you once again. Thank you, everyone. I'll end up the session.